processing, a system that are designed to speed up the execution of program by dividing the program into multiple fragments. It's also an evolution of serial computing where the jobs are broken into discrete parts that can be executed concurrently. Three models that are commonly used in building processor. First, synchronous processor, each with its own memory. Second, asynchronous processor, each with its own memory. Third, asynchronous processor with a common shared memory. Multiprocessor organization. First, single instruction, single data stream, SISD. Instructions are executed sequentially. Second, single instruction, multiple data stream, SIMD. All the processors receive the same instruction from control unit but operate in different set of data. 3. Multiple instruction, single data stream, MISD. Sequence of data and each processor executes different instruction sequence. 4. Multiple instruction, multiple data stream, MIMD. Several programs can execute at the same time. SMP is called symmetric multiprocessing. It is a technology in which programs are processed by multiprocessors and they share a common operating system and a memory. These processors communicate with each other through a shared memory. Symmetric means each processor can do anything with which the other processor can do. All the processors can make change to the any blocks of the memory and can also do input-output module communication. SMP performance issue. First, workload concurrency. The primary performance issue that is unique to SMP system is workload concurrency. Only one processor in four-way multiprocessor system is doing useful work at any given time. It is no better than uniprocessor, possibly worse because of the extra code to avoid inter-processor interference. Workload concurrency is the complement of serialization to the extent that the system software or the application workload or the interaction of the two require serialization. Workload concurrency suffers. Second is throughput. The throughput of an SMP system is mainly depend on a constantly high level of workload concurrency. More dispatchable thread than processor at same time cannot compensate or for idler processor at other time. The amount of load contention, the degree of processor affinity. Third is response times. If the program constantly has two or more dispatchable threads, its response time will probably improve in an SMP environment. If the program consists of a single thread, its response time will be at best comparable to that in a uniprocessor of the same time. Advantage of SMP. First, specification. In symmetric multiprocessing, each processor are designed to handle all the tasks. Second, reliability. It's more reliable as failure in one processor do not affect the other processor. Third, performance. SMP has high performance due to parallel working of processor. Fourth, design implication. It is difficult to implement a SMP as we have to achieve the synchronization of the multiprocessor. Fifth, speed. The speed of the SMP can be achieved by adding the processor. Sixth, cost. It is less costly because all the processors may have shared resources.
Okay, now I'm going to explain about cluster. Cluster is one of the multiple instruction multiple data stream, MIMD, which a distributed memory that can be lightly and loosely connected. Cluster is a group of computers that work together. It divided into nodes and each of it have a specific task to be accomplished. The components of a cluster are usually connected to each other using fast area networks, with each node running its own instance of an operating system. All the nodes uses same hardware and the same operating system, although in some setup different hardware or different operating system can be used. As what you can see, we have three types of cluster, which is load balancing cluster, failover cluster, and high availability cluster. For a load balancing cluster, it is a cluster node that share computational workload so as to As what you can see, we have three types of cluster, which is load balancing cluster, failover cluster, and high availability cluster. For a load balancing cluster, it is a cluster node that share computational workload so as to enhance the overall performance. For example, a high-performance cluster used for scientific calculation would balance load from different algorithms from all web server clusters, which may just use a round-robin method by assigning each new request to a different node. This type of cluster is used on a form of web server, which is web farm. Next, we have failover cluster. Where failover cluster is the function of switching application and data resources over from a failed system to an alternative system in the cluster is referred to as failover. These types are used to cluster database of critical mission, mail, file, and application server. And lastly, we have high availability cluster. It is also known as HA cluster. It offers a high probability that all the resources will be in service. If a failure does occur, such as a system goes down or a disk volume is lost, then the queries in progress are lost. Any lost query, if retrieved, will be serviced by different computers in the cluster. This type of cluster is widely used in web, email, news, or FTP servers. The scaling of the resources, which is cluster node, memory capacity, I/O bandwidth, and many more, leads to proportional increase in performance. Both scale up and scale down are needed, depending on the application demands or cost effectiveness consideration. Second, cluster job management. Clusters try to achieve high system utilization. Out of traditional workstation or PC nodes, they are normally not high utilized. Job management software is needed to provide batching, load balancing, parallel processing, and other functionality. Next, fault tolerance and recovery. Cluster of machines can be designed to eliminate all single points of failure. Through redundancy, the cluster can tolerate fault condition up to a certain extent. And lastly, availability support. Cluster can provide cost-effective high availability with lots of redundancy in processor, memories, disks, I/O device, networks, operating system, and many more. There's few advantages using computer cluster. First, cost efficiency. Using computer cluster is much cheaper as compared to mainframe computers. Next, for the processing speed, computer cluster has the same processing speed as mainframe computer. For the expandability, cluster easy to be expanded by adding desktop workstation to the system. And last but not least, high availability of resources, which explain if one of the nodes fails, another node will continue to provide uninterrupted uninterrupted processing. Compared to mainframe, if the system fails, the entire system will also fail. Summary: as computer technology has evolved and as the cost of computer hardware has dropped, computer designers have sought more and more opportunities for parallelism, usually to enhance performance and in some cases to increase availability. Parallel computer architecture adds a new dimension in the development of computer system by using more and more number of processors. In principle, performance achieved by utilizing large number of processors is higher than the performance of a single processor at a given point of time.